Now that we've spent some time developing the midpoint formula, hopefully you've noticed for most goods, the result would be negative. It's common to use absolute value when using the price elasticity of demand, and this is another characteristic of the midpoint formula. The demand curve is generally downward sloping, therefore, the percentage change in price and quantity will generally move in opposite directions. That means one will be positive and the other negative. Both a negative value divided by a positive and a positive divided by a negative result in a negative value. The common convention is to use the absolute value so that we can focus on the magnitude of the answer. Remember, we are really trying to quantify the consumer response to a price change, describing the difference between 2 points on the demand curve. As the numerator in the midpoint formula, the percentage change in quantity, as that gets larger, the resulting number gets more negative, which is actually getting smaller. For example, if a firm lowers their price by 10%, the denominator is negative 0.1. If the response by consumers is to buy 20% more, then the numerator is 0.2. 0.2 divided by negative 0.1 is negative 2. Now, what if the response by consumers was larger, an increase of 30%? Now the result is negative 3. The result is smaller, but it describes a larger impact, or demand that is more elastic. Therefore, it helps to talk about elasticity in terms of the magnitude, or absolute value. We can also see from the formula that when the percentage change in quantity is larger than the percentage change in price, the result will be greater than 1. This is describing a situation where the response is bigger than the change in price, and this is called elastic because the quantity stretches more than the price change. On the other side, when the percentage change in quantity is less than the percentage change in price, the result will be less than 1. And this is called inelastic because the quantity doesn't stretch as much as the price change. If the two are equal, this is called unit elastic because the result will always be equal to 1. If the price elasticity of demand is 1.3, then a price increase of 1% would result in a 1.3% decrease in the quantity demanded, and this would be called elastic. If the percentage change in quantity was infinite, then the demand curve would be horizontal, and that would be called perfectly elastic. If the price elasticity of demand is 0.4, then a price increase of 1% would lead to a 0.4% decrease in the quantity demanded, and this would be called inelastic. If the quantity demanded did not change at all, then the demand curve would be vertical, and it would be perfectly inelastic. This essentially means that the price has no impact on a consumer's demand for the product. Now, it's worth thinking about these two extremes a little bit. It may seem like these are merely theoretical constructs. I mean, what firm can charge any price and leave demand unchanged? We're really concerned with using elasticity over a small range of prices. Just like any extrapolation, the further you get away from your data, the more dangerous the conclusions drawn. However, the idea of perfectly inelastic demand is useful to think about necessities and goods that people must buy. And perfectly elastic demand is useful to understand goods like commodities, where there's no difference between products from the consumer's perspective, and any increase in price by one firm will just lead the consumer to a substitute good. So what we see here is that the magnitude is primarily what is of interest. The one risk in using absolute value is that we lose the ability to distinguish a good where price and quantity would move in the same direction. That's an upward sloping demand curve, and that's very rare. Most of us will be fine using the absolute value as part of the midpoint formula. Next, we'll look at some more characteristics of the midpoint formula, such as why do we use percentages?